Hi everyone! Today we are going to perform an experiment. The materials needed for this experiment are clear cups or jars filled with red cabbage juice, 2 stirring sticks, 1 tablespoon measure, 1 teaspoon measure, food items to test, and your food safety Google Doc. For this experiment, the food items we will be testing are 1 tablespoon or about 15 milliliters of vinegar, and 1 teaspoon or about 3.5 grams of baking soda. Throughout the video, I will ask you to make an observation or record answers to questions on your food safety Google Doc. When this happens, please pause the video while you record your response, and then resume watching the video once you have finished recording your response. First, we will add the tablespoon of vinegar to one of the cups containing cabbage juice. Stir to combine. Then, we will add the teaspoon of baking soda to another one of the cups containing cabbage juice. Again, stir to combine. Take a few moments to record your observations under Experiment 1, Question 1 on your handout. Your observations might have included a discussion of the color changes that occurred when the vinegar and baking soda were added to the cabbage juice. Adding vinegar generated a pink solution, and adding baking soda generated a blue solution. Why do you think this color change occurred? Record your answer under Question 2 on your handout. Before we answer this question, let's check the pH of each solution. We are going to use pH test strips. Each strip has 4 pads that contain an indicator that will change color when dipped in a solution. Match the pads to the color columns on the color chart and read the pH value at the top of the column to determine the pH of the solution. As you might know, pH values can range from 0 to 14, and a pH of 7 is neutral, pH values below 7 are acidic, and pH values above 7 are basic, which is also referred to as alkaline. The pH of foods is generally defined as a range of values instead of a single value. 1 pH test strip is needed for each solution, so we will be using 3 test strips. First, dip the test strip into the solution. Then match the pads on the test strip to the color chart to determine an approximate pH value. The pH of the vinegar and red cabbage juice solution is approximately 3. Vinegar is an acid. Now we'll test just the cabbage juice. The red cabbage juice has an approximate pH of 7 and is neutral. And last, we'll test the baking soda and cabbage juice solution. The pH of baking soda and red cabbage juice solution is approximately 8. Baking soda is a base. As a note, pH test strips are one method to test pH. pH can also be measured more accurately with pH meters that provide numerical measurements. Now that we have measured the pH, let's answer question 2. Acids produce hydronium ions in water, and bases produce hydroxide ions in water. When vinegar was placed in the cabbage juice, hydronium ions formed. Placing baking soda in the cabbage juice formed hydroxide ions. In this experiment, cabbage juice was an indicator, which means, like the test strips, it can be used to indicate the level of acidity or alkalinity by changing color. Red cabbage contains pigments called anthocyanins that interact with hydronium ions and acids. The anthocyanins interact with hydroxide ions and bases, resulting in a blue or green solution. What do you think pH has to do with food safety? Record your answer to question 3 on the Food Safety Google Doc. Certain pH ranges can promote or inhibit bacterial growth. pH can influence the safety of food products. It can be used to control the growth of pathogenic bacteria or bacteria that cause harm. In general, Pathogenic bacteria do not grow in environments where the pH level is 4.6 or below. High acid foods are foods that have pH values of 4.6 or below. Low acid foods have pH values greater than 4.6. The pH of low acid foods can be lowered through a process called acidification, in which a high acid substance, such as vinegar, lemon juice, or citric acid, is added to a low acid food until the pH level of the food is below 4.6. pH is not the only factor that determines how well bacteria can grow. Watch the bacteria growth video to learn about other factors that can be used to control pathogenic growth and promote food safety.